It has been 250 years since the double slit experiment, and that motherfucker only keeps getting weirder and weirder. So today I'll be reading mostly from this article by Anil Anathoswamy, which is excellently written out of Nature magazine, and then some from this Beyond Physicalism book of essays. If you don't know the double slit experiment, here's what the polymath Thomas Young told the Royal Society in 1803. If you take a single light source and shine it through two slits, you get an interference pattern. They don't just go through. It must be that light is operating like waves, and the waves interfere with each other, so at some points there's light, and at other points there's darkness. When this was reported 250 years ago, it was mind-blowing, and it disproved Newton, who said that light was a stream of particles. It turns out that light is acting as a wave. But as we started to learn about quantum, things only got even more weird. What if you tried to put a single photon, 1 unit of light, through two slits? What happens? They couldn't technically do this experiment until the 1980s, when a team here in France, led by Alain Aspect, did it. And what did they find? That the photon was both a wave and a particle at the same time. He won a Nobel Prize for this work. This wave-particle duality gets at the heart of what's weird about quantum. It is a probability of where it is. And so if you don't observe it, you have certain chances that it is somewhere. Once you look at it, though, the state of probabilities collapses into it goes through one slit or the other. So it exists in both states until it gets observed. Then, as this writer states, this creates its own problems. Imagine a real wave function that spreads for kilometers and kilometers before an observer detects the photon. At this point, the wave function peaks at the photon's location and simultaneously drops to zero everywhere else over a large macroscopic distance. This suggests a kind of instantaneous, non-local influence that bothered Einstein to no end. By the way, two controversial and fascinating theories that came out of this is Hugh Everett's many worlds interpretation, who says a new universe branches off every time this decision has to be made. There's also the more recent de Broglie-Bohm theorem, which says that there is an invisible pilot wave that is guiding all of these actions. But I think this sounds a little bit too much like God, and scientists don't like that one. This leads us to the great thought experiment from the legendary thinker John Wheeler called the delayed choice thought experiment. Imagine an experiment that gives you the choice of knowing which slit the particle went through. If you ignore that information, it continues to act like a wave. But if you access that information, then it stops acting like a wave and collapses and acts like one particle. So he had that idea in the 70s and 80s, and it was decades until Aspect's team could test it, and they found out that, yes, indeed, that is how it works in the real world. As this author asked, did the photon travel back through time and come back through the two waves as a slit? To avoid such nonsensical explanations, Wheeler argued the only way to make sense of the experiment was to say the photon had no reality. It's neither wave nor particle until it's detected. Though, if you look up retrocausality, the going back in time thing isn't so crazy. In a further refinement of that, in the 80s, Marlin Scully figured out how to entangle a photon with another photon. So because they're entangled, you can get information about one that's going to be true about the other. So if you keep them entangled, then they act like a particle because you can still get that information. But if you destroy the other one and that information isn't accessible, then it starts acting like a wave. So you're asking yourself, what does observation mean? And that's exactly what this essay in Beyond Physicalism by Henry Stapp is talking about. So the question that they answer is, where to make the cut? What counts as observation? If the data is just in the computer, does that count? Where is observation actually happening that collapses that probability of wave function down to a discrete particle? And John von Neumann, the famous physicist, faced this problem head on. What they found is the cut is very high up. If the information is in the microscope, it isn't yet observed. If it's in the computer, but not yet accessed, it's not observed. And it turns out it has to be observed by a human consciousness that collapses it. And so to John von Neumann, who got into mysticism basically because of this, it meant that we had these abstract egos that were not connected to our bodies, and the experiments did go that far. The cut is all the way up to beyond ourselves and into the consciousness that exists inside our brains. Does that sound spooky and non-scientific to you? Well, that's how quantum seems to anyone who looks at it. Read the writings of Dr. Nick Herbert for a great take on that. And the other question about cuts is, there's a question of where does the weirdness of the quantum world stop and the normalness of our classical world begin? And where do you make that cut? Where does the quantum stuff stop happening? And we don't really know, because the last thing I'll mention is in 2019, they actually did a experiment with macromolecules called oligoporphyrins, which I didn't know. But these are 2,000 atom big molecules. And if you send them through the double slits, you get the same kind of thing that you saw with photons. So up to 2,000 atoms, you're still having this quantum interference, dual wave particle thing going on. So we know it's at least that high. Maybe it goes all the way up to us. Maybe it goes all the way up to the whole universe. But whatever the double slit experiment is trying to teach us, we're still trying to figure it out.